Okay, so now we're going to look at some inequalities that involve equations with fractions in them. And you'll see it's a little bit different than just multiplying things out because we have to look at the intervals for our possible solutions of x. And I'll show you what I mean by that here, working on this problem. So we have this problem, x minus 4 divided by x plus 3 is greater than or equal to 0. Now we can't just multiply x plus both sides by x plus 3. I mean, that'll give us a possible solution. You know, that'll end up as saying x is greater than or equal to 4, but that won't give us the entire solution because when you have a negative divided by a negative, as you would if x is less than 4, then you would have a positive number, and if you got a negative number large enough, then that would also be greater than or equal to 0. So if we only say x is greater than 4, then that's not going to be the entire solution. So we have to look at what happens from this interval. We have to look at the interval from negative infinity to negative 3. Okay, and it can't be equal to negative 3 because then you'd have a 0 in the denominator, and that would give you an indeterminate. Then we have to look at the interval from negative 3 to 4, and then we'll also have to look at the interval from 4 to infinity. And we're going to leave this as not equal to 4 just because we'll have to test it out. It could be equal to 4, but we're not sure. So we'll look at this first interval from negative infinity to negative 3. And we'll do this just by picking any kind of, we'll pick a number that falls in this range. So we'll test it with a negative 5. So we'll just say x equals negative 5. And then we'll just plug that in. So we'll get negative 5 minus 4. And we'll get negative 5 plus 3. And we're going to test it to see if that's greater than or equal to 0. Well, we get negative 9 over a negative 2. And that works out to be negative 4.5, basically. A positive 4.5, excuse me. Then just to be consistent, we'll keep that as a fraction, so it's not to confuse. So we'll leave that as 9/2. So it's a positive 9/2. You got a negative divided by a negative. That is obviously greater than 0, so that checks out. So this interval does make this true. Well, now we've got negative 3 to 4 that we have to test. So, the obvious number that falls in that range is 0. So we can test that and say, okay, if x equals 0, then we get a negative 4 over 3, and that is not greater than 0. So that is not in our interval. So then we could look at 4 to infinity, and in this case we'll test 4 because we've got to see if this is going to be greater than or a greater than or equal to for the number 4. So we'll say x equals 4. So we'll plug this in. We'll say 4 minus 4 over 4 plus 3 greater than or equal to 0. Well, it is equal to 0. 0 over 7. So that checks out. So now our interval is, or for our solution is, it's negative infinity to negative 3 And then we say it's the union of, just by drawing a U here, 4, and then we have a bracket because that's equal to 4 to infinity. And the parentheses because it can't be equal to infinity. So that's our solution set. The range, negative infinity to negative 3, but not including negative 3, and also anything greater than or equal to 4. Now if we're going to graph this, and we'll just use the graphing program here to draw this out, and it'll be pretty easy as far as this goes. We'll just type it in. X minus 4 divided by x plus 3 greater than or equal to, oops, we have to move it over, greater than or equal to 0. And you can see we've got the graph here. Is this range negative 3 to negative infinity and 4 to infinity. So we've got an open space here. And you can't really see it, but this is going to be a dotted line because, like I said, it's negative 3 plus 3 gives you a 0 in the denominator, and you can't have that because you've got an indeterminate. So that's what the graph would look like for the solution of this equation. So the next question that we're being asked, similar to that, is got the inequality 5x plus 4 divided by 3x minus 24 is less than or equal to 0. So we have to, the numbers that we have to look at, the range that we'll have to look at is when 5x plus 4 here is less than or equal to 0. Excuse me. And then 3x minus 24. So the numbers that we're interested in are when x is equal to a negative 4/5 and x is equal to 8. So then we'll have these different ranges that we'll have to investigate. We'll have to look at what happens from negative infinity to a negative 4/5. We'll have to look at what happens from negative 4/5 to 8. And we'll have to look at what happens from 8 to infinity. So again, we'll do the same kind of thing that we did before. We'll test it, and for simplicity's sake, we're gonna, so we don't have to deal with too many fractions or anything else like that. We'll try to keep it simple. What's greater than negative 4/5? Well, what's less than negative 4/5? Negative 1 is less than negative 4/5. So we'll say x is equal to negative 1. So we'll get 5 times a negative 1 plus 4 divided by 3 times a negative 1 minus 24. And is that less than or equal to 0? Well, we'll get a negative 5 plus 4 is a negative 1. And then a negative 3 minus 24 is a negative 27. So that's actually going to equal a positive 1 over 27. Negative divided by a negative. So that is not less than or equal to 0. So this interval would not be part of our solution set. Now we look at from negative 4/5 to 8. And again, 0 falls into that category, so we'll say x equals 0. So then we'll have 5 times 0 plus 4 over 3 times 0 minus 24. So then we get a 4 over 24 negative. So that's going to be a negative 1/6. So that is less than or equal to 0. So that falls into that category. Now also we'll have to look at whether negative 4/5 actually falls into that range. And when we put negative 4/5 in there, then we'll get 0, and then this will be a negative number. So that would actually be equal to a negative 4/5. Excuse me, that would actually be true for when x is equal to a negative 4/5. So we can write that as a bracket instead of a parentheses, because that's going to be true when it's equal to negative 4/5. So one more test, we have to look at what happens when it's greater than 8. So again, we can pick any number except 8, so we'll pick 10. 10's easy to work with. So we'll get 5 times 10 plus 4 divided by 3 times 10 minus 24. Scroll over a little bit. And then we're checking to see if that's less than or equal to 0. So then 5 times 10 is 50, plus 4 is 54. 3 times 10 is 30, minus 24, so that's 6. And that is not less than or equal to 0. So the only case where this is going to be true is in this range from when it equals a negative 4/5 to 8. So that's our solution set in this case. It's from negative 4/5 to 8. And then we can come back to our graphing program, clear that out, and then we can type in 5x plus 4 divided by 3x minus 24 is less than or equal to 0. So again, there's the range that we just talked about. It's only in this range from when x is between negative 4/5 and 8. So that's how we would graph it. We would have a solid line here at negative 4/5, a dotted line at 8 because it can't be equal to 8, and then the shaded region would be the region where that equation is true. So that's how we would solve and graph those inequalities with unknowns in the denominator. You have to identify the points of interest essentially, and then look at the range. Look at how the inequality is solved in that range of interest, and then identify whether that inequality is true or not. So it's more of a test and a logic thing than it is solving like we did with the equations before.